Hello everyone, welcome back to my channel. First things first, if you haven't already, make sure you subscribe and click that bell notification over there, just like my friend. Okay, now let's get straight into it. It says if an integer n is said to be divisible by both 8 and 15, then n must also be divisible by which of the following? We've got 16, 24, 32, 36, and 45. Okay, first things first, remember what the word divisible means. Divisible is just another word for factor, i.e., for example, the number 20, right? Yeah, is divisible by 4, isn't it? Right? Hence, 4 is a factor of 20. Yeah? So factor and divisible, they're interchangeable terms, right? They mean the same thing. Yeah? Okay. So based on that, we know for sure that, well, 8 and 15 are factors, aren't they, of n. We don't know what the number n is, but we know that 8 and 15 are factors of n, right? Well, if 8 and 15 are factors of n, remember, the product of two factors is also a factor of that same number, isn't it? So we could therefore infer that, well, 8 times 15, which is equal to 120, is also a factor, right, of n. Yeah? Okay. So, and they've told us, well, it's basically say, well, if 120 is a factor of n, then what must also be divisible by n, given that 120 is a factor? Well, the only way you could have another number which is divisible by n, using the fact that 120 is a factor, it means that, well, that new number has to be a factor of 120 because there's nowhere else it could come from. So what you could do is you could get a factor tree for 120, right? So let's start and do that. Okay, so we've got 120. Let's just choose two numbers, 12 and 10. 12 times 10 is 120, that's fine. And we've got, well, here we've got 4, we've got a 3, and then here we've got a 2 and a 2. Yeah? And then here, this goes to 5 and a 2. Now, what we can do to help us, we can get the prime factors, can't we? Which we get that by circling the end of each branch, right? So we've got one here, we've got one here, we've got one here, we've got one here, right? So therefore, the prime factors of 120 are, well, we've got 3 2's, don't we? So we've got 2 times 2 times 2, yeah? And then what else? We've got a 3 and a 5, right? This simplifies to 2 cubed times 3 times 5, doesn't it? Yeah? So therefore, let me just scroll down so we just got a bit more room. Oops. Okay, that's about right. Okay, cool. So now we know that, well, 120 is equal to 2 cubed times 3 times 5, right? And, well, the number that is also divisible by n would have to be made up of these prime factors here. There's no other choice. So what you can do is for each question, for each option, A, B, C, D, and E, list the prime factors, right? Well, let's do the first one. 16 is what? 8 times 2, right? Which is the same as, well, 2 cubed times 2, which is 2 to the power of 4. Yeah, that's one. 24 is 8 times 3, isn't it, right? Which is 2 cubed times 3. That's it with that one. 32 is the same as, well, this is the same as 16 times 2, isn't it, right? Which is the same as 2 to the power of 4 times 2, which is 2 to the power of 5. And then what else? We've got 36, right? 36 is the same as 6 times 6, which is the same as, well, 3 times 2 times 3 times 2, which is equal to 3 squared times 2 squared, right? Then the last one, 45 is the same as, well, 9 times 5, which is the same as 3 squared times 5. Okay, now looking at all of these options, do any of these come from this factor here? Do any of these go into the prime factorization of 120? Well, you could see that A doesn't because you've got 2 to the power of 4. C doesn't because you've got 2 to the power of 5, and the highest power in the factors are 2 to the power of 3. That doesn't work. D, we've got 3 squared times 2 squared. There's no squared for 3, so that definitely doesn't work. We've got E, which is 3 squared times 5. There's no 3 squared equation, so that doesn't work. The only one that works is B. So therefore, the answer is 24. And you're finished.